So a vertical spring has 0.25 kilograms hung from its end. If the spring stretches 0.2 from equilibrium, what is the spring constant? So here are two key words that stood up to me, or key phrases. What is the spring constant? And stretched. So when I talk about putting weight on something and it causing an object to stretch out, when I talk about spring constant, I'm talking about this equation up here. Fs equals negative kx. So that equation is what we use when we're talking about the force stretching out a spring on an object. Now, we can use it to find the force anytime, even if it's moving and not just stretched. But this is usually what we use it for. Okay? So, F equals negative kx is what I'm going to use. So it's also important that you know what each thing stands for. We went over this in the notes, so if you need to look back at it, make sure you do that. F is force, K is spring constant, X is displacement. We're using X instead of D because D is from beginning to end, and this is not necessarily that. This is the amount stretched out. So it's a displacement stretched, but it's either stretched up or stretched down, and those numbers can be the same. So we just don't want to confuse it. That's why I don't use D. D is a little bit different. Okay? So F equals negative kx. So the first thing we need to do is decide what we're solving for, and that's k. Then we need to figure out what we're given. So we're given how far it's stretched, so that's x. And I usually make x a negative. Especially when it's stretched out, it's stretched down, so I make that down value negative. And then we're also given the mass of 0.25. So I'm ready to plug into the equation. So I'm not given a force, so I'm going to leave force blank for now. I'm solving for k, so negative k, and then my displacement x was negative 0.2. So what's my force going to be? Well, why is it stretched out? It's stretched out because of gravity. So because gravity stretches out, I'm going to use Fg equals mg. And I'll make sure to put that on the test. I don't want the reason you miss a problem is because that equation is not on there. I just assume that you guys have used that one enough. But it was clear that some people had forgotten it, or at least it didn't trigger in your brain. So I'll give that to you. You don't have to worry about memorizing that one. So I need to take the mass times 9.8. So 0.25 times 9.8. So when I'm solving this, the negatives are going to cancel, so I can get rid of those. So then I do 0.25 times 9.8. 2.45 equals k times 0.2. Divide both sides by 0.2. And you get k to be 12.25. K should always be a positive answer. So there's my value for k. So then in B, if the spring were displaced and allowed to oscillate, what would the period of the spring be? So now we're letting the spring bounce up and down. So now it's not just hanging there, it's bouncing up and down. So if we allow it to bounce up and down, what's the period going to be? So we're solving for period. Things that we know K is 12.25. We know the mass is 0.25. And the displacement now is different. The displacement before was how far it was stretched to begin with. Now we stretch it further. We don't know what that is, so I'm just going to leave x blank. I'm not going to include anything for x. So now we're talking about oscillating, and that is this equation here. Period is equal to 2 pi squared m over k. So period equals 2 pi square root of m, which is 0.25, over k, which is 12.25. So divide the 0.25 by 12.25 first. Period is equal to 2 pi times the square root of 0.02. So square root that number. You get period is equal to 2 pi times 0.143 and times pi times 2. You get the period to be 0.8 and 0.90 seconds. Okay. Anyone got any questions for me on how to set these up, how to solve them? Anything still confusing? Anything you want me to go over?
The last part.
How I got this 0.9? Is that what you're asking about? Yeah. So because it talks about oscillating, allowed to oscillate, that's how I knew to use this equation here. So then I just plugged everything in. So 2 pi square root of mass divided by spring constant. And then it's just plug and chug the math from there. So divide those two numbers to get 0.02, square root that number to get 0.143, and then multiply by 2 pi to get 0.9.
Okay, I'm still confused by the square root and the squaring.
You mean like why I do it or how I do it? How to do it? So since I know everything under the square root, I don't need to square everything, right? We've squared everything to get rid of the square root. We don't have to do that because I know everything under the square root. I only square everything if I don't know what's under the square root. So like if I was solving for mass, then I would need to square everything. In this case, I just do it on my calculator. So I divide those numbers first to get this number, and then I use my calculator to square root what that number is. So I didn't have to do any weird math, just the math that's there. Yep.
I can't see the board. Did you get 2.84?
For what? For the answer?
For, period.
No, I got 0.9.
Oh, I did something wrong.
I can see what you did real quick.